Hi, this is Mr. Bledsoe, and in this video I'm going to show you some strategies that you can use to figure out a math problem when you're stuck. So the math problem we're going to look at is problem number 1 from the North Carolina Math 1 EOC 2016-2017 released form, and there's a link underneath the video where you can pull up a PDF of all of these released questions if you don't already have them. And what I'm going to start with is just a quick scan of problem number 1, just a few seconds to scan and kind of get a general sense of the problem. So I notice that it looks like this has something to do with bus rides, and I notice that all of the answer choices are graphs of straight lines, which tells me that this probably has something to do with linear functions or graphs of linear functions. Okay, so let's go ahead and start reading the problem. Jesse's bus ride to school is 5 minutes more than 2/3 the time of Robert's bus ride. Okay, and I'm going to stop right there and notice that this question is a little bit confusing. I'm not entirely sure what it's saying, except it's apparently telling me something about how long Jesse's bus ride is and how long Robert's bus ride is. Okay, knowing that, and knowing that I've got these my four answer choices are graphs of straight lines, I can imagine that a question it might ask is which of these graphs represents how long it takes Jesse to get to school, or which of these graphs represents how long it takes Robert to get to school. Okay, so let me read what the actual question is. Which graph shows the possible times of Jesse's and Robert's bus rides? Okay, so apparently the graphs represent the times of Jesse's and Robert's bus rides together. Okay, so one of these 4 graphs is apparently related to this confusing sentence. Can I figure out which graph matches this sentence? Okay, well, one of the things I know about linear functions is that you can represent them in different ways. You can represent them as graphs, which is what the answer choices are. You can represent them as words, which is kind of what this sentence here is. And you can also represent them using algebraic notation, most often in the form of an equation that looks like this: y equals mx plus b, which is called the slope-intercept form of a linear function. So if I could represent the graphs using this equation, and if I could represent maybe this sentence using this equation, maybe I could match them up. Okay, so let's see. Y equals mx plus b. Okay, so I notice for all of the graphs that I have in my answer choices, Jesse's bus ride is listed as the y-axis. So apparently y is going to stand for Jesse's bus ride, or I guess more specifically, the length of Jesse's bus ride in minutes. I'm just going to call that J's ride. And the x, the independent variable along the horizontal axis, represents Robert's bus ride. Okay, so that leaves m and b, which I know m stands for the slope and b stands for the y-intercept. Also notice that I have 2 numbers up here in my sentence, 5 and 2/3, which might give some of you an idea of where this is going. And if you want to pause the video here and see if you can take it from here, then I invite you to do so. So, okay, I've got y equals mx plus b. Maybe 2/3 and 5 are going to be m and b, although I'm not sure which is which. So let me see if I can take this sentence, and maybe I can turn this sentence into an equation, and then maybe that will help me match it up here. So let's see. Jesse's bus ride to school is 5 minutes more than 2/3 the time of Robert's bus ride. Okay, this has got a lot of stuff in it. I'm gonna kind of break this into chunks here. And the 2 easiest chunks are Jesse's bus ride and Robert's bus ride. In fact, I could make an equation out of this if this sentence were a little bit simpler. If Jesse's bus ride were exactly equal to Robert's bus ride, I could just write this. Jesse's ride, the length of Jesse's bus ride, is equal to the length of Robert's bus ride. Now, I know that's not what the sentence says. I've just simplified it just to kind of give me a way to get started on how I could turn this into an equation. Okay, so Jesse's bus ride equals Robert's bus ride, if it were that simple. Okay, I know it's not, so I got to go and add in some of the more complicated parts. Jesse's bus ride to school is 5 minutes more than 2/3 the time. Okay, this whole 2/3 thing is, that's kind of confusing, but this part is not quite as confusing. If I left out this 2/3 time and just had it read, Jesse's bus ride is 5 minutes more than Robert's bus ride, actually I'm going to say 5 minutes longer, because that's easier for me to think about. Jesse's bus ride is 5 minutes longer than Robert's bus ride. Jesse's bus ride is 5 minutes longer than Robert's bus ride. So that means Jesse's bus ride is longer by 5 minutes. So in order for those to be equal, I would have to add 5 onto Robert's, however long Robert's bus ride is. So if I add 5 minutes to the length of Robert's ride, that's how long Jesse's ride would be. Okay, now we're getting somewhere. But now that's only this part and the two bus ride parts. I'm still leaving out this whole 2/3 of the time. So let me see if I can add that in. Jesse's bus ride to school is 5 minutes longer than 2/3 of the time of Robert's bus ride. Okay, so 2/3 the time of Robert's bus ride. I remember that of usually means multiply. So 2/3 of Robert's bus ride, 2/3 the time of Robert's bus ride. Well, if I multiply 2/3 times Robert's bus ride, put that in parentheses, 2/3 times Robert's bus ride, now I have an equation that reads Jesse's ride equals 2/3 times Robert's ride plus 5. Jesse's bus ride is 5 minutes longer than 2/3 of Robert's bus ride. 5 minutes longer, 2/3 of bus. Okay, so now I have this equation that's starting to look kind of like my slope-intercept form here. In fact, if I take this part here, which is Jesse's ride, and if I just swap in the variable y for that, because y stands for the length of Jesse's ride, now I have y equals 2/3 times, and if instead of Robert's ride I just write x because the x represents Robert's ride, now I've got 2/3 x plus 5, and now I have something that looks an awful lot like my point slope form. I've got an equation that has a slope of 2/3 and a y-intercept of 5. So now I can see, is there some way I can match up this equation with one of my 4 graphs? Alright, so I'm going to start by looking at the y-intercept, because I can see pretty easily what the y-intercepts are of my 4 answer choices, and I notice that answer choice B and C have a y-intercept of 5, which matches my equation, but A and D do not, so I can immediately eliminate A and D. They don't have the right y-intercept. Does one of those graphs, B or C, have a slope of 2/3? Well, I could probably actually calculate the slope using some points on each of the graphs. I could plug them into the slope formula, but notice that I might could do that more quickly, since 2/3 is a slope that's less than 1, and since I know a line with a slope of 1 is an exact 45-degree angle, then a slope that's less than 1 must be flatter than that. And since answer choice C is steeper than a slope of 1, that it must have a slope that's greater than 1. And answer choice B is the only one that has a y-intercept of 5 and a slope less than 1, so answer choice B must be my answer. Now, just real quickly, let's take a look at the different strategies that we used in solving this problem, even though we were stuck. So after we did the scan, and then after we read through that kind of confusing sentence, and we started to kind of compare it to our answer choices, notice that we used what we know about linear functions, that we can write them as y equals mx plus b, and we noted that we could take this sentence and we could kind of translate it from English words into mathematical symbols, which is what we did. Notice, however, that we didn't go directly from this sentence, we didn't go straight from this confusing sentence to y equals 2/3 x plus 5. we kind of had this in-between step where we wrote down something that looks kind of like an equation and also kind of like a sentence. So we kind of use this as, you know, a way of getting from this confusing sentence to the actual equation that we were looking for. So those are some techniques that you can use, some problem-solving techniques that you can use on problems if you happen to get stuck.